Core system login in progress.
Okay, made a little mistake here. Jump back down to our evaluate code on our base shape, and on the create side for the top and the bottom, change those to the correct create sides. It's create side 4 and create side 5. Notice that in reviewing the video. Let's jump up to the top. Underneath the update, we're going to do our very first function, or method, actually. This method will be called on a child thread. I have not finished my fields yet. Forgive me. Excuse me there. Okay, so I'm going to go ahead and make my base shape public because it will be one base shape for each group of chunks later on. So each chunk will have to be able to access it. Normally I do 3 by 3 chunks per common, although they're not all neighbors with each other. I like to keep a copy of the height map for debugging. You can create a bitmap with that if you want. Our array of materials, now our array of presets, our xorg for our chunk, our zorg or origin for our chunk, because we'll use it a number of times and I don't feel like calculating. We shouldn't calculate it over and over again. Index will be used later on. Now, let's see here. These two fields are mainly when we go to multi-chunk, but we'll go ahead and put them in there right now. Now we can jump down to generate and get to work. So we initialize our nuggets to the, oh, that's just wonderful, Microsoft. Okay, to the level size times the maximum height, the maximum possible height, not just to generate height. That caused a bug one time for me forever. Now we're going to use our noise generator finally. We've gotten to it. And we multiply our height times our generate height. So first thing we're going to get is an index for our height map. So this will be a 2D index. And we'll just cast the H to a byte. So now I'm going to loop through. We only actually generate our chunks once in the end. So I'm going to loop through from the Y to the maximum height. I'm going to get the 3D index now for where this guy is, what its index is inside of our nuggets array. And if our Y is less than our height, then it'll be a shape, it'll be a chunk, or a cube, excuse me. Otherwise it won't be. And don't worry, we won't be here that long. We'll just default the material to 0. Change that soon enough. Now at the bottom, set the state, next state for our state machine to state or to pre-evaluate and say that we have been generated. So whenever we have multiple chunks, a neighboring chunk may be evaluating and it needs to get some nuggets from our chunk to evaluate the correct shape. Can't do that until we are generated. Therefore, if this chunk is not generated yet, we act like there's nothing there. And we just go ahead and create all the sides in that horrible way. If you do pooling properly, you'll never run into that problem. But we still need to know that this chunk made it through generation, was generated, and we need to be, the other chunks need to be able to say, okay, you're generated, give me this nugget. All right, and our very simple pre-evaluate method, but necessary. Our current in is current mesh we're on. And that'll make more sense shortly.
Access granted.
Alrighty. Evaluate function. The evaluate function will be called on the child thread like the pre-evaluate and generate. If a function does not access any Unity object or does not create any Unity object or set any Unity object's properties that Unity is setting at the native level, then it can be called off thread. If, for instance, any property that we're going to modify in this function, it calls a method like on the mesh object that causes Unity to do something on the native, at the native level, at the C++ level, then it will fail. And that's one of the areas where Unity will just not give you an error. It will just do nothing. But in this case, our evaluate function okay, I did that totally wrong. I have no idea what I was thinking. Made no sense at all. So from wherever we broke, if we got close to our vertex limit and we broke off to our nugget length, we're going to process. Now, we actually check for the break inside of here. Okay, maybe my keyboard's dying. Maybe that's it. I'd like to get the nugget. Just because it's easier. Now, we're going to be practicing non-conditional, unconditional, or just programming. Non-conditional or unconditional programming, or matrix programming. Really popular along the Gulf Coast of the U.S., I guess. Not popular in the whole country. But with it, we don't have to do this if statement when we get there. Right now, since we're doing things this way, we have to, well, we don't necessarily have to, but we need to check that our shape is not equal to nothing. And using arrays as a way of removing conditions is an old technique. It's not really new. In fact, enums, one thing that really drives me crazy is that we actually have to create these constants. It doesn't drive me crazy, but it's kind of annoying that you actually have to create a constant where we want to use these as integers or as bytes instead of just using the enum itself as a byte, as an index. And that will become much more understandable once we get our mesh library in place. But right now it's probably sounds just like a fairy tale to you. No conditions. Okay, so we need to get our neighbors. Won't you be my neighbor? So change your shoes, get comfy. We got to get our neighbors. I guess people outside the U.S. may not get that reference. Okay. First, we're going to get a neighbor 0. If our R is greater than 0, if our row that we're passing in is greater than 0, then we have a neighbor behind us. If not, see, what I'd really like to be able to do is say neighbor dot neighbor 0. But of course, it's not going to allow that. And that's just a very personal pet peeve. So I'm going to show you two methods doing this real fast. This method we're constantly calling our getCR. And that's kind of annoying when we're trying to get rid of everything. But if we pass in our nugget index of the actual nugget we're passing, and we have it, it's right here, it's in, we can say nugget index minus our nugget count for this one. And that will give us the nugget right behind us. Because our nugget count in this case would be 3 by 3. So I'm on 0, 1, 2, 3, 4. If I subtract 3, 1, 2, 3. Or subtract 3 from 4, we get 1. Pretty easy. And we don't have to actually call a method. Because we would be calling it up to 28 times, depending on how large an area you want to check on. Right now we're just worried about our direct neighbors. So now we're going to get neighbor number 2. And we're going to go ahead and draw our outer wall all the way around. But if you don't want to, if you want that just top look, you just set these to 1. And I'll say that again when we get to the front end. But all right, so neighbor 2 is which neighbor? So 0, 1, 2. It is this time our nugget index plus our nugget count. So first, so our row plus, if our row plus 1 is less than our nugget count, we have a neighbor in front of us. If our column is greater than 0 this time, we'll get our neighbor number 1. And this one's disgustingly easy. And I'm just going to go ahead and grab this one, copy and paste. If our column plus 1 so if our column plus 1 is less than our nugget count, then it's our next nugget over. Okay, so now we got to get the neighbor on top of us. If y plus 1 is less than our map level max height, then we will have a neighbor above us. This time we're going up an entire level. It's the same one right above us. But now for the bottom, I don't want to draw the bottom. If we're at the bottom level, I don't want to draw it. So if our y minus 1 is greater than or equal to, let's go ahead and grab both of these. We'll get our neighbor below us. But if it's not, then in this case, we're going to go ahead and say there is a neighbor down there. We're going to lie to it. I'm not endorsing lying, but we are going to lie here. So, if that bothers you, realize that computers are not alive. And we're going to set our 0 to us. I do want to do a try catch here, because I want to know, was there an error either with getting our nugget, this stuff, or is there an error actually in our base shape that we're not catching? And we don't, yeah, we got the base shape, okay. CYR, reference neighbors. We're passing our neighbors by reference because we're going to change them later on. And I hate to go back and just add this stuff in, so we're going to go ahead and pass it right now. Now, we're not going to test our break yet, but we are we're going to test for our break right now. But we're not actually going to test that whether we need to create another mesh if we went over our limit. So I'm going to go ahead and put the code in here because I've been talking about it. Just break out of there. And we set our state to the post evaluate.